Welcome everyone in our fifth day session. So today we will see complete almost half of our journey, right? It's 10-day session. And so primarily we have basically touched upon three topics, starting with basically the general signal processing where KL transform. Then later on we touch the image processing, and thereafter we had the detailed session on the biomedical signal processing, especially ECG, EEG. And thereafter, this is the biomedical is one part, and then the scale transform one part. Then we touch basically the GSP. We explored the GSP, the what is in the GSP. GSP is actually primarily my research area. And see, fortunately in India, fortunately or unfortunately, there are not many researchers who are in the GSP, and GSP is very, very emerging field. So that way our session was, few sessions were based on GSP, and when I presented my students' work with whom I am doing, I am learning many things. Ram Nivas, basically EEG work, Manisha is facial recognition work. So, so one is basically the biomedical signal processing, another is GSP, another is basically the KL transform, and along with it, image processing. So four aspects actually we have touched upon in our half hour journey. And in our
maybe arguing
so am I audible? At least. So see, we have actually today is actually we will complete half of our journey. We started from 26. So it is 10-day program. So 5 day we will complete it today. So we have mainly touched upon the four topics, right? Primarily the what we say that KL transform, that is one of the topic with another biomedical signal processing where we covered the topic like the ECG, EEG, and then we covered in the second part. In third part, we covered basically the GSP. GSP one a new topic in this GSP. We fortunately or unfortunately in India there are very few researchers who are working in GSP. So with God grace, I got the chance to work in this area when it started in 2014, and I applied that area in facial expression recognition. And I'm telling you, it was a very, very uh, difficult but special journey because seeing the concept, the paper which we discussed yesterday, it's a not very easy topic. When only paper is there, no implemented work is there. But during that journey, during that my PhD journey, I learned many things, many interesting things which I want to share with you, my research student. Some works which I presented, like the GSP in the EAG, again, it's work of my student Ram Nivas. Then I presented the GSP along with the facial recognition, that is the work of my another research student Manisha. And even the work, subsequent work today, which I will present it, biomedical application. This is again the work of my student Suman. Fortunately, she is also attending it. So that is the thing. So these are the three topics. Fourth one is basically the image processing. Side by side, it is image processing is going on. It is not necessary that you must apply the GSP everywhere, but it is only one of the approach available. See, when we come to the workshop, definitely I was discussing with Anand what is the primary objective of the students to attend the workshop. Can you answer? What is the main motivation? Those who are attending it. What is the prime objective, main objective when we come for this workshop? signal processing, its workshops are not very common. What is your main objective? Those participants who are attending it, can you mention? Only. So in case of Suman, don't need to mention because I asked him, please Suman register that you can learn other things. Anand also, I asked him to please register so that you can learn other things. What about the Krishna? You very frequently attend the workshop. Can you mention your objective? What is in your mind? Snehal, Vimal Prakash. I think Vimal Prakash, I've never ever seen your any comment in the chat box. Krishna Singh, I've given my answer the day before, yesterday, you remember. What did you answer? See, many things were there. Those who are presented means what is your means what is the key thing, first thing in your mind that you will get the advantage. Please feel free. It may be the certificate also. Sometimes we have the requirement that our institute asks us to give the certificate based training. Many times we feel that yes, we should have certificate. There's no problem. Even many times I also attended many workshops to get the certificate. That is yes, real situation. But you should feel free to share. I am not going to make any impression regarding anyone. See, all are at their every stage. Even see, only one thing is in quiz marks, that is also objective marks. But as expected, if I go to the PDF, probability density distribution function, answer is very less likely to come, hardly from one or two participants. Anyway, no problem. So we move to, I think this is a more difficult question, right? But at least you don't answer it. That is not a problem. But at least you should ask the question. That is my expectation. You must ask the question. Whoever is the speaker, so that it seems that you are involved. Whatever doubt you have, irrespective of the relevance, significance, at least you are there. It shows your presence. Right? Okay, no issue. So now coming to the part, digital signal processing approach on the biomedical applications that is presented by me and mainly prepared by the Suman, as I mentioned earlier. So it is basically the contents of digital signal processing advantages of DSP in medical field, DSP in image analysis, application of DSP, biomedical image analysis, idea of Fourier transform, graph signal processing, overview of GSP analysis on biomedical image. So what is digital signal processing? So signal can be defined as something that conveys information. There are basically two types, analog signal, digital signal. So signal processing refers to analyzing, modifying and synthesizing the signal to get a desired output. See, remember these three words, it's really seen but they convey very much essence. Analyze, modify, and synthesize. Are they all the same or the different one? Means why? Means what is the common difference? Definitely, when they are coming in the separately. So can somebody tell about their difference? All you are the related with DSP. So that at least that you can share to. Even say yes, Krishna, I'm seeing good signal processing approach apart from using the raw data directly deep learning approaches. Thank you. To see some good hands on GSP, fine. I'm expecting few incoming session. To know current trends and new methodology, fine. Vimal Prakash, I hope you would have got some new methodologies, trends. Now my question is that what is basically when you are saying analyzing and modifying? See, or you all are senior people in signal processing. At least you have gone through it. So can you tell what do you mean by analyze? What is small difference between analyze and modify? Krishna is answering analysis when some information signal is available and we are extracting the information out of it. Okay. Okay. What about modification? Remember, if you recall this approach, y equal to f. See, when you see this word y equal to fx, so what does examine the characteristics features, right? Okay. So remember, see the key thing. See, whenever we say analyze, so what, as it is said that it is extract information. But what is more important in analyze that whether something is increasing, whether something is decreasing, what is happening, what type of relationship is there, right? Directly related, indirectly related, because whenever signal processing, only signal processing word is there, this is more about the mathematical in nature. This feature extraction, etc., when we come to the application part, right? So, analyze means what type of relationship is there. Direct independence, indirect, whatever it is there. Then modifying means whether is it the desired one. Whether when you want to process a signal, is it the actual one which you want to get it? No, if it is no, then you modify and then synthesize the signal. What do you synthesize? And then as a resultant, your new signal has come. Means from the original signal, what was you expecting? Your original signal, and in this way it is a synthesized. So it is basically a chain that we are saying. Whenever signal processing only discussed, it is again it has mainly the mathematical essence. When it comes to the application level, then it becomes basically the this feature information extraction, etc. Or in the realistic life. Analog signal can be converted into a digital signal. So as we are saying that it is of two types, analog and the digital. So it important thing, all the realistic signals, what we are, for example, my speech signal, for example, the image, actual image, all these are basically the analog signal. When we but for the representation part, for the processing part, by our machines, by our algorithm, we convert into a digital signal by sampling or quantization. Analog signal is converted into a discrete signal, then it is converted to a digital signal. Even that's why you would have seen the rule of the Nyquist theorem, Nyquist sampling theorem. Because you want to convert everything into the discrete form. So how many samples? Again, why it is required? It is required because we know that when we convert our signal into a discrete time signal, it is it requires very less memory. It is also very system convenient. It can be very easily processed by the microprocessor or the microcontroller, whatever it is there. That's why it is required. Because my computer or my, say, specifically my microprocessor, for them, discrete signal is the best one where they act up instead of analog. Because why it is so? Because see, VLSI, all the hardware is very well implemented to process the discrete signal. That is the key thing. So now we come to the word digital signal processing. Digital signal processing refers to analyzing these digital signals to get the desired outcome. Again, the word digital signal processing is analyzing these digital signals to get desired output. But remember, when we are saying this word, it doesn't mean that it doesn't contain modifying and synthesizing. That is also equally part of it. Because when we are analyzing it, definitely we will modify it, it leads to the synthesis. So it contains both the meanings also. In this diagram also you can see here, it's simple one here, voltage is there. Voltage, it is when it is converted into it is converted into a digital form, 0, 1, 0 bits here, and then this will look. Advantage of digital signal processing. So what we are going to in this part, it is here securing data, it is to signal in digital format for analysis, extraction of signal from noise, it is compressed data. So many things. See, the best example of basically application of DSP is in the communication. Whenever we are transmitting those messages in the 5G, 4G, so see, we all basically transmitting these digital signals only. It also requires the compression because there is no meaning to send the complete data over a line. It will even increase the amount of the traffic. So it is better to compress if it doesn't lead to deterioration in the quality. Extraction of signal from noise. Noise has become a major issue that we always want to extract out. Remember the key contribution in one line. If somebody asks the contribution of DSP, it is what thing? Can you tell? It is filter. If you really ask what is the key thing, it is basically the filter. Different type of filters have been designed based upon the DSP. This is the very, very fundamental contribution of the DSP. Now coming to the part DSP in the medical field, see here, see in hearing aids here, those people who are working in the speech, etc. They know that how the speech signal in different way it is processed. It is amplified, it is very well tuned, etc. So all these filters, etc., are there in hearing. ECG, in ECG here you are seeing the diagram, different electrodes are there. Because see what we see at our heart at the different volt, we can sense it from the voltage level, we can sense it that what is the state of our heart. If there is some problem, definitely it leads to a sudden hike in the voltage, etc. So we are, and the best thing, remember, heart always continue to work till we remain in this life. It continues to work and it continues to tell the state. Our state can be monitored. Even these days, you can see the very special smart smart watches there with the help of your pulse. The health of the state is continuously monitored. Blood pressure monitor. So what are things? These things. These are basically the signals. These are signals which conveys the information about our heart, about our blood pressure. This is hearing aid. It is a small electronic device that you wear in or behind your ear. It makes the sound louder so that person with hearing loss can hear. Hearing aid is primarily useful in improving the hearing and speech comprehension of people who have hearing loss that results from damage to the small sensory cells in the inner ear called ear cells. Even see if you would notice that actually naturally also we would have some hearing mechanism. There things are amplified, things are processed out. So in the same way, the hearing aids are also designed on the same line. How hearing aid works on the principle of DSP, that is also has been shown to you. The sound is basically picked up by the microphone, right? Picked up by the microphone and converted to an electrical signal. Remember, whenever we can, whatever process, whatever things, the best thing is to work upon electrical signal, which has some voltage, some current. So, with the help of the transducer, we are basically to convert into it. And once we are converted, then it is in our domain, electrical signal, but not of the very high magnitude. And then we digitize. The digital signal is then filtered to selectively amplify those frequency bands in which patient shows the most severe hearing loss. So what is the problem? Problem to the patient is that it is some frequency bands are there where it is not amplified. So what we say, we filtered out that reason. We filtered out it and then amplified. Amplitude compression in the system. What is amplitude compression? Digital signal is there, variable bandwidth. It is now filtered digital signal. Now it is amplified. Now it is amplified filtered digital signal. Now amplitude compression. Why amplitude compression? In which the system gain is reduced when the amplitude exceeds some predefined threshold value. In order to avoid excessive loudness to the ear is also used because of the delicacy of our eardrums that is to be taken care. Finally, the pre-processed digital signal is converted back to analog. Why? Because as a human in the real life, we are always aware. We find it for us only analog signals matter. Digital signal is basically thing which can better processed by the machine, better can taken care by the our computer related devices. But in real life, it is the analog only. So it is converted into a desired analog signal and it is delivered to the ear via ear. So the most beautiful thing here is that it is all in the real time. Whatever process that takes place, you never ever feels that some external process is happening. So DSP in the image analysis, so image processing is a method to perform some operation in image in order to get an enhanced image or to extract some. So now, as we have already discussed, we have discussed complete one lecture where we processing means we perform some operation on an image. The purpose maybe you want to enhance the some detail or you want to enhance the complete image or to extract out some feature or any objective or any classification. So it's a type of signal processing in which input is an image and output will be image or characteristic of that image. So what we're saying, how we can relate it with the signal processing in general DSP, if we say image processing. In image processing, definitely input, etc. is the input, either input is an image or output in an image, where image is definitely involved. That is image processing, that is the relationship between DSP and the image processing. Image processing basically consists of 3 steps. Why are we doing it again? Because we want to go to the medical image. So again, recalling those. Image processing basically consists of 3 steps: acquisition, analyzing, manipulating the image. So 3D world captured by camera and sent to a particular system to focus on a water drop. And then it gives an output as an processed image. So it consists acquisition, analyzing, manipulating the image. This is in a same way as like our earlier one, analyzing, modifying, and synthesizing. Where it is acquisition, analyzing, and manipulating. So when we come to the thing DSP in the image analysis, so what we are doing in this image analysis is basically we are so what is in the image analysis when we are going through this word? Image analysis, it is basically the image acquisition, as we discussed, it is the one part. Then it may lead to the image enhancement, it may be the image restoration. For example, you are getting some satellite image, you want to restore it. What is it actually like, right? Color image processing, wavelets and resolution processing, compression, morphological processing, segmentation, representation and description. And then it is the object recognition. So if you see on the output side, it is object. These are the things. Segmentation, as we have already seen in our earlier last time, that we want to segment the image. For example, in occluded faces, we saw it. And compression, these are the in-between processes. What do you know the wavelets and multi-resolution processing? Wavelets is basically, again, if we want to get the both the things. So the image that at what time, which frequency is present. So this thing is easily available from this. So DSP in image analysis, if you see, recall this is cameraman picture. Here, if you see, it is the original picture, and then it is a filtered one. Sorry, it is the filtered one. So how we are able to get it? If you do at the operation level, you can when you convolve with some filter. You recall in our image processing lecture that we have discussed what we convolve with, we basically convolve with some patch 3 by 3 basically we circuit. So if you recall, it is basically the mean filter. As you here it has been multiplied in. So we are getting the GX. It is the same things in DSP in the image analysis as also discussed on that day, that it is also helped to find out the Sobel edge detection. We are able to know the edges, right? Here we are input images